everyone, welcome back to the channel. So today in this video lecture we're going to be solving this problem of find first and last position of an element in sorted array. So in this problem we're given an array of integers nums sorted in non-decreasing order. We have to find the starting and ending position of a given target value. So if target is not found in the array, then we'll return a pair of integers containing -1. We must write the algorithm with big of log and runtime complexity. So let's better understand the problem statement using an example. So here we have an example. We have this sorted array containing 6 integers and a target 8. We want to find the first and last occurrence of this target in this array. So we can see that we have an array like 0, 1, 2, 3, 4 and 5. So the first occurrence of the target is at index number 3. The last occurrence of the target is at index number 4, and we return this pair for this given array and target. Fine. So how can I solve this problem? So remember the definition of lower bound in the same series that we explained. So a lower bound of any integer in the given sorted array is the very first occurrence of that integer, okay, or if it is not present in the array, then the very first occurrence of that integer which is just greater than target. That is the basic definition of a lower bound. Namely, like in other words, you can say the position of the very first element at least equal to the target. Like here target is 8 and the position of the very first element at least equal to the target is 3, and the position of the element which is okay, so this will give me the very first occurrence of the target if it is present in the array, and it is given that it is obviously present in the array. So finding the lower bound will give me the first integer of this pair. Now how would I find the last occurrence? Now it can also be found used by the lower bound function. How? Let's say for target is 8. If I find the lower bound for target plus 1, and in this case it is 9, what will it give me? It will give me the very first occurrence of that number in the array which is at least equal to 9. So here it is 10, at least equal to 9, or it can be greater than 9. Obviously it will be the very next integer to the last occurrence of this target. Fine. It is the obvious conclusion from this fact. Fine. So the next occurrence, the last occurrence of this target will be just the previous element for the lower bound of target plus 1. So find the lower bound for target plus 1. It will give me the next integer to the last occurrence of the target. Like here in this case it would be 5. Okay. Now if it is not the case, now once I find this position, I will simply subtract 1 from this position, and and that will constitute my second element in the pair. Like here in this case it will be 4, and I will return 3, 4 for this array. Fine. So you got the idea. Find the lower bound for the target, find the lower bound for the target plus 1, go to the position, like the previous position for the lower bound which we have found for the target plus 1, and simply return these two positions as the pair, which will give me the first and last occurrence of the target element in the sorted array. Fine. So I hope you got the idea how we are going to solve this problem, and you know the definition for the lower bound function. So let's jump to the code implementation part. So here we have our search range function. In this function we'll simply in the very first we'll calculate the lower bound for this target in the nums array. So first occurrence will be nothing but lower bound for the nums array, like for the target in the nums array. Okay, and the last occurrence will be lower bound in the nums array for target plus 1 minus 1. Okay. Now I have to check if this first position that I have found is a valid position. If it is a valid position, so if it is less than the size of the nums, and at this position we have the target element, and for this first position I have the target element, I will return this pair, that is first and last. Otherwise I will return a -1 by default. Now let's write the definition for lower bound function. So lower bound function, it takes in this vector nums, okay, and the target number, find the boundaries for low and high, okay, initialize an answer variable. So answer will simply store the lower bound, and it is n if or it is equal to the nums dot size, it is initialized. Now run the usual binary search, low is less than equals to high, find the middle element, high minus low by 2. If at the middle element, if the nums at the mid element is, if it is greater than equals to the target, then I will, this can be the lower bound. So store answer here, nums mid, or mid rather, and high to mid -1. Reinitialize the range to like from low to mid -1. Otherwise reinitialize the range from mid +1 to high. Fine. So in this fashion we are going to perform the binary search. At the end return the answer, which is the index of the lower bound, which is actually the index or the answer right from the end of this function. So let's see if it works. Okay, it got accepted. Let's submit it. So it got accepted. So that's all. It's a standard problem, and the time complexity for this problem is big of log n. Why? Because we are just performing binary search twice. So big of log n to the base 2, and the space complexity is constant because I am not using any auxiliary data structure. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel for more such content, and I hope to see you all in my next video.